Hi guys, this video is about radioactive decay. Radioactive decay takes place among those atoms whose nuclei are unstable. So that's one of the things you need to remember is this only takes place when the nuclei is unstable. That is, the nucleus, for some reason, because of the protons and neutrons which are housed in the nucleus of an atom make it unstable. And this usually takes place, this instability is there in elements that are above number 80 in the atomic number 80 in the periodic table. Okay, so there are three types of nuclear decay: radioactive decay, alpha decay, beta decay, and gamma decay. Alpha decay, when it takes place, it gives us an alpha particle, which is essentially 2 protons plus 2 neutrons. So as you know, protons and neutrons make up the mass number. So when you have 2 protons plus 2 neutrons, that's equal to 4 for the mass number. Because it's 2 protons, that's also same as the atomic number. We're going to put 2 here. Remember the nuclear symbol, how we do it? And when you look in the periodic table, the mass number of 4 and the atomic number of 2 is helium. And if you want to be sure of that, here we have helium right here. Okay, it's the mass number. Remember, whenever you're looking at the element, the smaller number is the atomic number or number of protons, and the bigger number is the mass. Okay. So remember, every time there is alpha decay, you're always going to get the mass, you're always going to get an helium atom. So let's take a look at a nuclear decay of, an alpha decay of uranium-238. And the atomic number is 92. So if I tell you that it's an alpha decay, you're automatically going to put an helium atom here. Plus, now what you want to put next is, you want to take 238. So whatever is on the left side of the arrow has to equal to whatever you put total of this side, okay? Top and bottom. So 238 minus 4 is 234. So we're going to put the mass on top. And then 92 minus 2 is 90. Put 90 at the bottom. Now, how do you find out what element it is? Remember, the periodic table is organized by the atomic number. The smaller number on the element is the atomic number. The periodic table is organized by the atomic number. So here's my U, right? We started with that. And then the element, it says, is 90. We came up with 90. So I go back into my periodic table and see which has the atomic number 90, and that's thorium. So go ahead and put TH here for the symbol. Notice the left side here adds up to all of this is equal to the right side here. Okay, what I mean by that is that the 238 here adds up is equal to this 4 plus 234, 238. This 92 is equal to 2 plus 90, and this is called conservation of mass. Okay, so now let's talk about beta decay. So beta decay happens when the nuclei is unstable, but the neutron in the nucleus becomes a proton. So if a nucleus becomes a proton, that changes your atomic number. And an electron is given out. Okay, so if you have a question where they say that the the neutrons are unstable, or there's a neutron becomes a particle, a proton, then that's a beta decay. Okay, and always an electron is given out. Okay, remember electrons, I put 0 here because electrons don't have any mass and they have a charge of -1. So, so the element that comes after the arrow, it's going to have a bigger atomic number. Okay, so the proton number is going to change. So the beta particle is going to be this electron here. You're always going to have this electron. So when you see an electron given out on the other side of the arrow, that's a beta decay. So just to give you an example, let's say you have thorium here, the same thorium here. I'm going to go ahead and put it here, 234 and 90. And notice, do not look at the mass number that we have here and compare to see what's on the periodic table, because these are the isotopes. So the periodic table mass number for this thorium might be different, okay? Or it might be the same, but know that you're supposed to use the mass number that's given to you in the problem. Okay, so 234, I put the arrow. Remember, I told you that the electron is given out plus. Now the proton number is going to change. You're always going to increase the proton number, increase proton by 1, okay? So which means if this is 90, I'm going to put 91 here. The mass is going to stay the same, okay? Mass is not going to change because all you're doing is, remember, the mass is made of neutrons and protons. So if you're taking the protons, all you're taking the neutron, it's converting into proton. You're just changing the proton number, and mass is going to stay same. So I'm going to go back into my periodic table and see which one is 91, and that's right here, Ba. So go back and put that in the equation. Same thing. This is 234, that's 90, and that's 91. Okay. So now gamma decay is where there really is no new element formed. It's only energy is given out. And that is large amount of energy is given out. Okay. Gamma rays have short wavelengths, which means that they have really large amount of energy. So let's take a look at this image, and I'm not sure if I clarified it in the class, but alpha decay can be, alpha particle can be stopped by a paper, okay? Beta can go through a paper, but it can be stopped by metal, like aluminum, sheet of metal, or in this case, like wood is stopping it, okay? Gamma can go through the paper, wood, and it can be stopped by lead. In some cases, gamma can be stopped by concrete as well, but you need a thick brick of concrete. If it's a thin brick of concrete, thin concrete wall or something, it can go through, but a thick concrete wall or lead in this case can stop it. So remember, alpha is the least penetrable, okay? And then beta, and then gamma. Remember that. So if we were talking about the amount of energy associated with penetration ability, then alpha is the least amount. Alpha, beta, and then gamma. Okay. So I hope this clarified. One of the key things to remember is that the alpha and beta are the ones that will create a new element, whereas the gamma is only energy.